So, we will see this some planes and how to find out the direction of those planes, as well as the. So, to define the planes we use the negative indices also. So, just I will give one example from where things will be more clear. So, and this is C direction. Okay. So, just let me so this so parallel plane one can so these are parallel planes. If you want to draw more, right. See, if I draw one more plane other side, then just let me remove this. Okay. So, what is this plane? So, this plane immediately you can say that is the 0 1 0 plane, 0 1 0 plane, right. So, planar distance. So, from the origin we take the normal distance of that one. So, in this case it is the normal distance, it is the normal distance. So, it is basically B value. In case of cubic crystal it is A, that we have seen for 1 0 0. So, what we are seeing 1 0 0 0 1 0 0 0 1. Okay. So, for all these planes 1 bar 0 0 0 1 bar 0 0 0 1 bar. Okay. So, these are the planes. The planar distance is A. Planar distance is A for basically for when it is cubic crystal, right. And these planes basically, so 1 0 0 plane. So, this is 0 1 0. If you draw these planes on this axis, okay. So, similar set of parallel planes you will get. So, that will be represented by 1 0 0. Other, if you take planes intersect on C axis, so you will get this plane. So, in all cases this will be the planar distance, and these all planes basically it has same property, you know, it has same property. So, it is written in a third bracket like this. So, it represents, to represent a family of planes which has similar property, same property. Okay. So, those plane together is represented by with some one of them their indices in a second bracket. So, it represents the plane family. So, if I represent with this 1 0 0 in second bracket, so it represents basically this one of any plane. Okay. So, these are the plane family, and negative, you see here, just here I have drawn this picture to tell you that this these are the plane, these are all represented by single indices, Miller indices, set of Miller indices HKL. So, 0 1 0. So, for this plane which is passing through the origin, so here it is difficult to tell this is 0 1 0 plane, okay, because it has not cut B axis at unit 1, right. So, that is why for any plane, so we take the distance from the origin, assuming that there is a plane at the origin, parallel plane at the origin. Okay. But to find out the Miller indices of this plane which is passing through the origin, basically what we do, we just shift, translate towards the nearest plane, and for that either you can translate this one, translate in this to the nearest plane. So, one has to translate by the value this b unit, okay, 1b by 1b. If it is 1b, this is 2b, this is 3b, right. So, it will coincide with this plane. So, it is translated towards b axis with 1b value, okay. So, now whatever the indices of this one, so that will be the indices of this one, okay. So, these the indices of this one is 0 1 0, so that is why it is 0 1 0. Now, other side here, now to find out the indices of this one, if I go other direction, okay. So, then what I have to do, if it is origin O, so this is the minus 1b, okay. So, it will be translated towards opposite direction of b axis by value minus 1, okay. So, then this plane basically 0 1 bar 0, okay, 0 1 bar 0. So, plane wise you can see this 0 1 0 0 1 bar 0, these are same plane, okay, these are same plane. So, that is why this 0 1 0 0 1 bar 0, these are the same plane, only directions are different. In this case, this direction is towards positive direction, and for this plane it is towards negative direction. So, here actually I want to discuss that about the crystal direction, or direction of a lattice or of a crystal. So, crystal direction. So, you have a crystal, so it has unit cell. So, if this is the origin, and this is the A, this is the B direction, B axis, and this is the C direction, C axis, okay. So, direction of a crystal, so from the origin or may not be through the origin. So, it can be, so you want to find out the, so this is the unit cell of the crystal, but in a crystal you have this, you have basically the many unit cell, and if you want to find out the direction in the crystal, this is the direction you want to find out, okay. So, to find out the direction of the crystal, so wherever the line you have drawn, so that is a parallel line we can take, which will pass through the origin, So, if it is the parallel line, So, if it is the, so this is the direction we want to find out. So, if it is not passing through the origin, so just we shift it to the origin, and then we can find out the direction of this along this direction, what is the how we can represent the direction. So, we use some so this some value to represent the direction of the crystal. So, how to find out those value? So, basically you know the, if you have a axis system, so if you want to find out the direction, so take a point on this, line, and what is the coordinate of this point, one can find out. What is the coordinate of this point, one can find out, right? One can find out. How to find out that? You know, if we have a axis, x axis, y axis, z axis, and it's the they are perpendicular to each other. In that case, so this point can be x y z, okay, right. So, in this crystal system, so this point we write basically in terms of axis unit. So, unit is basically A, B and C in terms of that. So, U A, V B and W C, right, W C. So, in terms of that axis unit, so A, B are always, it is there. So, in terms of that unit we can write U V W. So, this point we can write U V W. That means U times A, it is, one has to go U times A and then V times B and then C times C to this point. So, that is the coordinate, right. So, whatever this coordinate we got, so that we take to represent the direction of this line, okay. So, that will be the direction of crystal we want to find out. So, that is written in third bracket, these indices are written in third bracket U V W, right. So, when indices are written in third bracket, so it is basically representing the direction of the crystal, and we have seen that when it is indices are written in first bracket, so it is representing the crystal plane, and when it is represented in a second bracket, so it represents the plane families which have the same similar property, okay. So, let us take example. So, what is the direction of a crystal plane, okay. So, direction, so crystal plane we find out also the planar spacing, right. And now, if I want to find out what is the direction of this of a crystal plane. So, direction of a crystal plane, you know, it is represented by the direction of the normal of that plane from the origin, okay. So, from the origin, if you draw the normal on a plane, so that direction of that normal is basically the direction of the planes. Okay. So, for these planes it is 0 1 0 planes, 0 1 0 plane, 0 1 0 plane, right. Now, what is the direction of this plane? So, basically the direction of the normal to this plane. So, what is the normal to this plane? Normal to this plane is basically this, right. Normal to this plane is this, no? Right. And this normal to this plane is basically this, means this. Okay. So, this is 1b, right. So, normal to this plane, so this from origin this the, so what this is the foot of the normal on this plane, and what is the UVW value? UVW value for this point, UVW value is, so it is on b axis, that means x is 0 along the a axis, this there is no, we are not going towards a axis. So, this is 0, u value is 0, v value is 1. As I told, we write this v times b, but we write in terms of b unit. So, that is 1, and this along the c it is 0, right. So, v value is 0. Okay. So, this is the UVW value, basically coordinate of this foot of the normal on this plane. Okay. So, what will be the direction then of this? So, as I told, we will write in a third bracket, right. So, from here you can see that the Miller indices we have used for the planes, that is 0 1 0, and direction of that plane is basically this UVW, this having same value of HKL, right. So, we can tell that if it is HKL value of a plane, so direction of this plane, that is normal to this plane, that can be written is in third bracket. So, that is using the same Miller indices, we can represent the direction of the crystal. Okay. So, thus we can find out the direction of any plane. So, say if you take a diagonal, so you have cubic, you have a unit cell, say cubic unit cell, right. So, if you take a point, just on the along the diagonal, right. So, this is one corner, this is just opposite corner. So, this will be the diagonal, this will be the diagonal. So, what is the direction of this? So, the direction, so what is the coordinate of this? That will be 1a, 1b, 1c. So, that means 1 1 1, that is the coordinate. Okay. So, along the body diagonal, if that is the direction, so that direction can be represented by, so these are the coordinate, right. So, that coordinate I have to put in, a third bracket. So, that will be the direction of this, and you can show that this diagonal is basically, it will be normal to the plane 1 1 1. Okay. So, which one will be the plane? So, basically, so this, so if I consider this, point and these two, okay. So, this will be the this will be the 1 1 1 plane, right. This will be the 1 1 1 plane. Okay. This will be the 1 1 1 plane, and if you take normal on this plane, this 1 1 plane, if you take normal on this plane, so then you will see that the direction of this normal is basically this. Just you can do yourself, it's not difficult job, so you can find out. So here about the direction of the crystal. So basically whatever Miller indices we are using, so for basically cubic system, whatever the Miller indices we are using for defining the plane. So that's the that we are putting in first bracket, and when and direction of this plane is basically this can be represented with the same Miller indices, and we put them in a third bracket. So, third bracket represents the direction, first bracket represent the plane, and second bracket represent the family of planes which have the same properties. Okay. So, thank you very much. We will continue in next class.